Hey folks, how's it going? So today actually we're going to be looking into this problem called happy number. So lead code equation 202. So we are told that we need to write an algorithm to determine if a number is happy or not. So what is a happy number? So a happy number is defined by the following process. So it's starting with any positive integer and we need to replace the number by the sum of the squares of its digit, right? Then we need to repeat the process until the number equals to 1. So if the number does not end with 1, then um, it's going to be false. That means that it's not a happy number. So it has to end with 1 for the number to be happy. So for you to understand this question better, let's make an example, right? So we can see that here we're given 19. So because of we need to square these two digits, so we're going to square 1, we're going to square 9, and we're going to have to add these up. So by doing that, we gonna get, I think it's gonna be 82. Then we're gonna repeat the same process whereby we have to square 8. When we have to square 2, then we're gonna add these up. Then I think this is gonna give us what is it, 68, right? Then we're gonna square 6, and we're gonna square 8. We're just repeating the process. So until we get to 1. So we're gonna get 100, right? Then here now we're gonna square 1, we're gonna square 0, we're gonna square also this 0, then we're gonna add these numbers up, then this is gonna give us 1. So this is a happy number. So we do know that 19 is true. So this is a happy number. So you can see that we just wanna repeat this process like so. So now let's look at an example whereby we do not have a happy number. So let's take example at the number like 2, right? So we're gonna do the same thing. We're just gonna square 2. So when we square 2, we're gonna get 4, right? Then we square 4, we repeat this process, we just gonna get 16, right? Then we square these two digits, which is 1, which is sorry about this, which is you're gonna square 1 and you're gonna square 6, then you're gonna add these number together, then you're gonna get 37. Then you repeat the same process, you square 3 as well as you square 7, then you're gonna get 58. All right, so you square 5 and you square 8, then you add the results up, then you're gonna get 89. So you can see that we are still continuing. We haven't reached 1, so we still need to continue with this um, with this uh, with this process. So we square 8 and we square 9, then we're gonna get, I think it's gonna be 145, right? Then we square these three numbers, it's gonna be square 1, square 4, square 5, then we add them up, then we're gonna get 42. Then we square 4, we square 2, and we add the result up. Then we get 20. We square 2, we square this 2, I think. Then we square this 0. Is that correct? Which is, we're gonna get 4, right? Then we realize that actually we were here. So 4 is here. We did actually process 4. So this means that this is not going to be a happy number, because what will happen is that it's going to be a loop. So you can see that we're going to just repeat the same calculation. So this two here, we're going to have to return false. Okay. So that's essentially what we have to do. That's how we have to solve this problem. So let's get into the code, and I'll explain how we're going to solve this problem. So now coming to the coding portion. So just to iterate on the thinking process. So we said that when we are given n, the number. So what we need to do is that we need to replace this number by the sum of square of its digits, right? And we need to repeat this process until we get to 1, right? So if we get to 1, then we're going to return true. But If we do not get to 1, meaning that as we continue this process, we realize that actually we are processing some of the numbers that we already have processed. That means that we're in a loop. So this is not a happy number, then we have to return false, right? For instance, if you have a number, then you continue to square the digit up, then at some point you get a 4, then you square 4, you get 16. But as you continue squaring the 16 digits, you continue that process, you end up getting 4 again. That means that you're going to repeat, you're going to go again to 16 and continue that process. So you don't want that. So that's why we're going to need to pretty much know if we have already processed this number. So, and if we have, then we're gonna have to return false because anyway, we're gonna end up in a loop. But let me just write the code so that you get to understand. So the bottom line is that we're gonna need hash set because we're gonna have to actually check if we have processed this number, right? Like I explained that this is quite important because you don't want to, if we have already processed the number, we don't want to process it again. Like that means because of we're going to end up in a loop. So which means that we need to check if we haven't processed this number, right? So if our visit dot contains, we're going to pass this as a reference, and as long as we haven't processed this number, then we're just going to continue searching for one. But if we have, then we unfortunately we're going to have to return false because we know that we're just going to end up in a loop. So the first thing that I'm going to do is just to make sure that I insert this number because we are processing it currently. So I'm going to insert it inside the hash. And I'm gonna make sure that I sum the digit of this number. So I'm gonna have a function which is called sum of squares, which is gonna be responsible for that squares. Yes. Okay. And whatever this sorry about this. I think I made a typo. So whatever this function is going to return, we just have to check if this number equals to 1. Then if it is, then we're just going to return true as instructed. Else we return false. But the bottom line here is that the sum of squares essentially is going to square the digit of the number, then it's gonna sum them up, then it's gonna return that value. Then we are kind of like replacing now that number, right? So now we need to define this function. So which is the sum of squares. Okay, sum of squares. Then this is gonna be a mutable value. Then there's gonna be type of i32. We're just gonna have to return type of i32. Then we're gonna say let mutate some values, which is gonna be equals to 0. So essentially some values is gonna be, because remember that we have to square the digit of n, right? So and we have to sum them up. So that's why we need that sum of value. So there's a quite a trick, right, that we have to do. Remember that we need the digit from the number. So let's say the number, for instance, is equals to 12. So because we need the digit, we need 1 and 2. The question is, how do we then get 1? Right? So one way to get 1, essentially, we can say we can divide 12, right? We can take 12 and divide it by 10. So this is going to give us 1.2. Then because we're going to apply an integer function, this is going to give us 1. Right? So you're gonna make sure that this is not a float, it's an int. So int is gonna remove that point something, then it's just gonna return 1. Now the question is, how do we get 2? So to get 2, we can actually use a modular function. So we can mod 12 by 10. This is going to give us the last element because it's like the remainder. So how many times that's 10 goes into 12? It goes once. Then there's 2 as a remainder. Then you get 2. Okay, so 2, that's what you're going to get. So, but the punchline is that we need these digit, and that's how we're going to extract them from number. So I'm going to say while n essentially is greater than 0, right? I'm going to say let mutate. So I'm going to say mutate digit. So I want to get the last element. So it's going to be n mod by 10. So this is going to give us the last element. So we know that this last element we need to square it up. So we're gonna update n by saying n equals to divide n divide by 10. So we are saying that we are essentially removing what is it, the last element, right? Because the last element is going to be the digits, so it's going to be some values. It's going to be plus equals to digit, and this is going to be squared digit. Then what I'm done, I'm going to return some values. So just to explain again, I don't want to confuse you any further. So you can think we have n as 12, right? So what we're doing here is that we're saying that, okay, we're going to extract the last digit, which is 2. Then here we update n to be the 1. So we update it because of this is going to update n. So this is say n equals to, so we're dividing n by 10. So this is going to give us the first digit, like I showed you with 12 example. Then this while loop here is just going to continue. Then when n has run out, then it's just going to be 0. Then this thing will return. I hope that makes sense, right? Because I think this might be tricky if you don't know some of these stuff. But I think this code should work unless if I made a silly mistake. So we are mutating n, but essentially we haven't declared it as a mute type. So we just need to do that, right? So you're just gonna say n it's gonna be mute because of I think we are modifying it here. So I think that's what we needed to do. It looks like our code is working fine. So I'm going to submit and make sure that everything is fine. And it is. So yeah, I think this is it. I really appreciate it, guys, for tuning in. This is essentially the algorithm, how we solve this problem efficiently.